Harry Hughes. I'm Advanced Computing Leader with the Dow Chemical Company. We're situated within R&D, so we focus on the unique IT needs of research and development within the company. And in my department is high performance computing, scientific data analysis, and scientific data analytics.
Hi, I'm Trevor Mason from IRI. We've had I was telling the guys there, we've had a few name changes over the last 10 years or so. I'm the Vice President of Technology Research. What that means in essence is I help to manage change. You know, we've heard a lot over the last day or so that things are changing very fast. So we have a core engineering and development team, and their job is such that they don't have the time to investigate all the new things that are coming up out there. So we form this team where we go out, we invest, we look at all the new technologies that are out there and decide which ones we should adopt. And once we've adopted something, even those change every week. So we have to keep on top of how the technologies we have adopted change and when we should implement like a new version of software or hardware into the company. An interesting thing about IRI is unlike most companies where the data center is the back office, you know, it supports the primary business of the firm. At IRI, data processing is the business that we do. So we are a market research firm. We collect a tremendous amount of data every week from all the large retailers throughout the US and Europe. We process it, we standardize it, and we serve it back up to a variety of the clients. And so doing this very fast every week is incredibly difficult, and managing the technologies associated with it is a challenge. So that's, in a nutshell, who we are and what I do.
Great. Kirk. Okay, so I'm Kirk Bourne. My friends call me Captain Kirk. I'm a professor of astrophysics and computational science at George Mason University in the School of Physics, Astronomy, and Computational Science. And though I've done all of those things in my career, what I am actually doing is data science. So I advise students and teach data science at the university and do research in that area, but also I do a lot of external independent consulting in the area of big data analytics and data science. So helping businesses make those digital transformations that analytics will bring.
Great. So big data means something different to everybody, right? What does big data mean for you at Thomson Reuters? What do you do with big data?
Yeah. First of all, if I may, Alex, 2 seconds on what is big data, right? To me, I think there are 2 big aspects of big data. One big aspect of big data is really about using the right set of technologies to transform your very large data in a very, in a less expensive way, really, really fast. So how do you actually take and ingest all the different set of data? But to me, once you have that, and that's where all the focus has been of how you ingest all these different kind of data sets, structured, unstructured. But once you have all those different kind of data sets, what you do with it, and I think that is a bigger challenge, right? And therefore, I think that big data has 2 things. One is from a technology aspect of how you ingest all these different data sets, and then 2, what you do with it, and what technologies or tools you have, what you do with it. In our world, in Thomson Reuters, we deal with a lot of capital market firms, and so we deal with all these different kind of exchanges. For example, we have customers who ingest 400 different exchanges throughout the world. Now, if you think about it, these exchanges have different formats, different, all different kind of sets. How you normalize it, and to me, that is a big data also. If you're setting up a new firm, a hedge fund, if you want to actually do back testing, how do you do that? So if you look at IBM or any other Thomson Reuters or Dow Chemical, anything, you look at it, how you do that. So we have these tick-by-tick data, petabytes and petabytes of tick-by-tick data going back to gazillion years, right? So how you use that, and then the thing is, again, from a storage perspective, that is one part, but then what analytics comes on top of it. And last but not the least is that this world we are living in, where the Facebooks and the Twitters and the social media that brings in a totally new aspect to this whole world of capital markets. People want to make alpha, so how you make it, and you know, that's another aspect that's coming into the forum.
Great. Kerry, what is big data at Dow? What are you doing with big data there?
To me, simply, big data is a problem that requires a distributed approach to be solved. And our classic client-server type architectures, a very small set of computational capabilities required to make things happen. But big data is where you tip over into, we've got to have some sort of distributed approach in order to make this even, feasible.
So did you develop your own system, or are you using what?
Well, we have a variety of efforts underway. In some cases, probably what's unique about us, and something that I think has not been talked about a whole lot here, is the required domain expertise needed to apply big data approaches to solve a particular problem. So with us, it's materials science, it's molecular modeling. So how do you take this person who's very deep in the chemistry and yet connect them with a set of skills that allow them to solve problems with the computational approach? And so yeah, in some cases we're developing our own codes where we take advantage of graphics processing unit cards and in an environment to generate millions of design of experiments, run those in silico, and it helps us to focus on a particular slice of the pie where we think the next generation ethylene oxide catalyst is going to be available to us. So a lot of our approaches to big data are to help us be smarter, and where we actually take things into the lab or into a pilot plant to help us save money on getting that. It's basically an insight generation system where we don't know something, we construct a system that helps us to get there faster.
So that's is that more pure research, or are you developing products, or?
Yes.
Yeah.
So there's some aspects of that which are more greenfield exploratory type of domains. There are other aspects where we know we've got this product and we'd like to be able to take it a little extra in a certain property or property structure relationship so that we can meet a particular client's needs.
Okay, great. Trevor, what are you doing with big data and IRA? I know you are doing some Hadoop stuff, right?
Yeah, so what do you do with big data? Well, with all the data that we collect from these retailers, there's two components to it that I see. One is the data itself. So you have the facts which come in, which is in this store, 20 cases of Pepsi was sold on this day at this time. So we have the fact. And then you have the dimensional elements, which is the description of the product. And there's all kinds, for any given product, you could have typically anywhere between 10 and 50 attribute descriptions. But those 10 to 50 attribute descriptions vary by product. So a lipstick wouldn't have the same attributes as a soft drink, for example. So across those, we have several categories that we manage things in. So there's the descriptive elements and there's the facts. So those by themselves are large, right, when they come in. So the database of facts is on the order of, it isn't big data, but on the order of 20 terabytes. But what happens is then the implicit big data is when you cross that 20 terabytes with the over 2,000 descriptive elements on the product dimension alone, and then on the geography dimension, which is where. So there's another 500 descriptive elements on that, and you can drill. And those are the elements, i.e. the attributes themselves. And then each attribute can have any number of values. So the color attribute, for instance, can have God knows how many values. So what you get from that is a combinatorial explosion. So the implicit big data that we have is in the petabytes when you cross those things. And what we have to do each week is that now you have to focus in on a client, so like a Pepsi, and a particular marketing manager at Pepsi, they just want to know how my particular product is doing in some region of the country at some time, and also gain some insights into how could I be more competitive. So, and what Pepsi is looking for from their description is different to what a cosmetic company would want. So you have to have the ability to kind of predict the kinds of things they want to look at and have that stage, and also at the same time for the types of things that you don't want to stage because it will go into the more than petabytes if you were to save everything, be able to dynamically go and bring that up as well in a reasonable amount of time. What that boils down to is for the fact table, when we use it each week, it has to be able to serve up more than, it runs at more than sustained 500,000 records being fed up in an ad hoc way per second. And that goes up into the million or more records being served up from this environment per second, 24/7. And it's not seeks or crops, it's random reads of this database. So it was on a mainframe, and we just transferred that successfully to a Hadoop infrastructure to serve this up. On the mainframe, it was proprietary BDAM. We did our own thing, that was a big data. It was Hadoop-like from the 1990s, and we tried several databases over the years to serve that up. It didn't work. We eventually got onto the Hadoop platform just last year, and was able to use it in that way. We also have big Oracle databases to serve up and manage the dimensional element and to maintain some of this data. So it's big data is a pain, it's a problem. It's the rate at which you need to search this data, join it with other things, and serve it up. It's always an interesting problem. And then there's just serving it up is one thing, and then there's doing advanced analytics on it to derive insights, which then drives it into another dimension. So because no commercial system could do these things, we've often built proprietary systems with very compressed architectures to help manage the types of problems we have with big data. And my job, just to wrap it up, is we always want to see, instead of building these proprietary systems, how can you use something open to do it and have somebody else have the headache about maintaining it. So this system that was on the mainframe was proprietary. We had it, and moved it into Hadoop last year was one of the big problems solved, so we no longer have to maintain that proprietary environment.
So for you, moving to Hadoop is a way to reduce costs and still maintain that data availability.
We have reduced costs, maintain, and we now have an update cycle. So this system we had proprietary, it couldn't do everything we wanted, and our in-house team, their ongoing development of it, it wasn't cost effective to develop the underpinnings to make it more flexible and SQL-like, let's say. And the Hadoop immediately gave us that. So it solved the problem we had before, but also gave us the additional ability to drive direct SQL against the database. In a proprietary one, it didn't have an SQL interface. It was going in on 3 dimensions and picking out the record. So it's almost like a hash into a very particular point, getting a record out, and throwing it downstream.
That's an interesting dynamic, is whether big data analytics, is that a business requirement, or is it helping customers become more competitive? So for you, it's kind of the former, right? It's just maintaining business as usual.
There's a business we are in, yes.
Captain Kirk, for your clients, are they seeing big data just as a cost center or a profit center? Are they trying to become more competitive or just keep up with the Joneses?
Well, I think it's some of both, and even in my mind, I sort of have a blur of distinguishing those two, because I see how it's one feeding into the other, that the investment is needed to be competitive, and of course, once you're competitive, then you're actually, can turn that into innovative new products, innovative new deliveries to customers and everything. And so what I find really interesting from my perspective is a lot of the things that I've done historically in my career as an astrophysicist in terms of collecting data on objects that move through space and time, that describes just about anything that we do in life. Okay, so whether it's a customer experience or a cyber hacker, that individual, that customer, that object is moving through space and time, some kind of space through time. And so any kind of analytics that works in one environment can usually find a home in some other completely different market. And so the very things we do to sort of monitor and detect whether an asteroid is going to collide with Earth and wipe out civilization, which, oh, by the way, we're trying to do to let you know when we're going to all die. Those same kind of predictive analytics can be applied, to Ebola outbreaks and to tsunami warnings, to cyber incidents, cybersecurity incidents, customer churn or customer conversion. So all kinds of different applications for a single sort of metaphor, which I like to use to define what I think what big data is to me. It's a very short definition. For me, big data is everything quantified and tracked. Okay, so now we're essentially putting a sensor on everything. Okay, so social media puts a sensor on the social sentiment of the world, right? And we have sensors in healthcare, we have sensors on the environment, we have sensors on climate, we have sensors on our customers. And we're tracking and measuring everything. There are, just as we just heard, hundreds if not thousands of dimensions of customers and products and events. And so tracking all of those things and collecting, measuring, tracking, and then doing discovery and decisions off of that. That's the big data world, as I see it.
Can you give me a specific example, maybe how your astrophysicist work is translated? I know you've done some work with retail.
Yeah, so as I said, my way back story in astronomy is that I did collision dynamics in galaxies, and so I was tracking orbits of stars and galaxies, and stars or planets in the solar system, whatever, they're driven by forces, right? I mean, gravitational forces, whatever, and they move in certain directions based upon these forces pulling on them. And so this trajectory and forcing model works, the metaphor works very well in the retail space, and I've actually done a lot of consulting with a retail marketing analytics company who is basically trying to create a model of customer behaviors. And so what is this model of customer behavior? It's basically a trajectory through some space, right? And so what are the forcing terms, and so specifically, they're trying to move to this new world of prescriptive analytics. That is, I can't really change the forces on the planets in the solar system, but I can change the forces on a retail, especially online customer experience, to maybe move that customer towards an upsell or a cross-sell, or to try to prevent an empty shopping cart, or try to prevent churn of a customer, drive that customer to conversion. So again, understanding that what the space is that the customer or that a client is moving through, and then identify that the things we can measure that sort of give us insight about that trajectory, and then also, once we have the insight, we know what kind of things we can change or manipulate to move them into the right direction. And so our asteroid deflection initiatives in NASA, or if we actually do detect an asteroid that's going to hit Earth, we want to be able to do something to deflect it so it goes somewhere else other than hitting our planet, right? So that's a perfect example of prescriptive analytics. Okay, sort of driving the thing to a good outcome as opposed to a disastrous outcome.
So we're going to track and triangulate everything, right?
Other quick that I do for a couple. Being in retail space from physics seems to be more common these days. So as you know, we are out of Chicago, and Fermilab is just on the outskirts of Chicago, and with CERN, with the new super collider that they have there, all the physicists are moving there. So we actually were lucky enough to hire an experimental particle physics out of Fermilab, who now work for us in this same retail space, transferring the data science he did at the particle level to consumer behavior in much a similar way as Kirk just described. So I found it.
That's very interesting, you know, what you said, because even in a capital market perspective, I guess we are seeing more of that. And obviously from a traditional perspective, you see market data, that's where people are generating alpha, that's where you're getting alpha. But over the course of year, I would say last 3-4 years, what we have seen is that there are some non-traditional ways of actually generating alpha. At Thomson Reuters, there are various, and I'll give you a few examples. I mean, it very much correlates to what you were saying. One is Weather Insight. We have a product, Weather Insight, where if you are trading on commodity and energy, we actually track each and every vessel, each and every boat, each and everything that is going all across the world to really let you know if that vessel will reach the destination at the right time or not. Or for that matter, Chicago, there are a lot of folks in here from Chicago, weather, how is it, what's happening? Not just Chicago, but overall. And if you are trading on wheat, or if you're trading on corn, how is the weather and how can you, so there is an element of predictive and prescriptive analytics in there. And more so, your news. Right, so again, that is another aspect that is pretty big, very big in that sense, where what we have seen from a prescriptive analytics in that sense is that if not only about positive or negative news that can actually make you money or lose you money, but also behavioral finance, which is another aspect in the big data and all this thing. So what we do is that we not only look at the positive and negative news items, but we also go one level up in the world of alpha generation, which is things like trust, joy, fear. And you mentioned Pepsi earlier. So if Pepsi comes out with a product called Pepsi Next, and if you're holding a portfolio of Coke, you want to look on the Twitter and Facebook and everything if the trust is up or down, and should Coke be coming out with Coke Next or not, and things like that. So the challenge here, as I said, started off earlier, is not only about the first part, which is not only taking the data and processing it, but it's about the tools of how you create big data into a product, not only just technology. And then that's where I think where the industry is going, and that's the fun part to me.
Interesting.
And the most challenging.
Yeah, most challenging, absolutely.
Carrie, what's one of the toughest big data analytic related challenges that you faced at Dow? How did you overcome that?
Well, we are in the process. I don't think we arrived at any sort of destination. I'll go back to the domain expertise comment that I illustrated earlier. I think we've touched on it in this conference so far, but academia is now generating talent that has that capability, that blended capability of domain expertise plus computational, right? And as a result, we're seeing a new generation come that's better equipped to deal with these things. But in existing companies today, it's very difficult to advocate to somebody who's used to taking experimentation done in the lab and realize that I can save you a lot of time if we did some of this work computationally. And so a large challenge is the culture shift from people who are accustomed to working in certain ways and being able to adapt that to a new world order, so to speak.
So how is Dow putting in place maybe culture or process changes to help you?
Yeah, so this is where the carrot works really well. And so success, I think, is one of the largest factors. Everybody has a self-interest in propagating their science or their career or getting the next promotion, and you find that the people who are getting the awards externally and internally, when you find that the most impact within the enterprise is occurring for people who are equipped and are doing these sorts of things, that's the best situation from a propagation of the technology and the technique across the enterprise, is that people take notice when people are successful utilizing a certain tool set.
Great. Kurt, what's one of the most unusual or unexpected lessons you've had in big data analytics? What jumps out at you?
Well, gee, there's so many of those, but I guess I'm constantly surprised, so it's a consistent thing at how something that I'm doing in one domain just spontaneously generates value in some different domain. And that's the thing that's really surprising here. And so I like to use the phrase transdisciplinary data science. So many people like to say data science is multidisciplinary, and that's fine, but I like to think of it as transdisciplinary in the sense that it transcends discipline boundaries. So I can actually, advise businesses and federal agencies, and healthcare and medicine and cybersecurity and retail and all kinds of things, which I know nothing about really. I'm doing a lot of work with the FDIC right now, and building a model of stability in the banking network. And every time we meet, I have to have them redefine their terms because I just still get confused the difference between an asset and an equity. Things like just very trivial things to a banker, but to me it's like, so we can have this conversation because it transcends discipline boundaries, the data science. And so just recently, one of these examples of spontaneous discovery of the transference of work in one that I'm doing to something completely different is I was invited to give a talk at a private nonprofit think tank in Washington D.C. They were aware of me and they said, hey, come give us a lunchtime talk on data science. So I gave this talk and I gave lots of examples from astronomy because I love astronomy, but also I think it works well again as a metaphor to demonstrate sort of the things I was just talking about a while ago. And so they invited me to write a little grant proposal because they gave out small grants to university researchers. So I applied for this grant proposal to analyze some galaxy data, multi-dimensional, high-dimensional galaxy data with one of my grad students. And so they funded me to do that, even though that means their work is in healthcare and government policy and cybersecurity and all kinds of stuff, right? So, but they said, this is interesting, we can use your algorithms in some of our work. So anyway, so I did this grant with my student, and we developed this idea of identifying sort of places where there are hidden variables in your data. So that is to say, there are things happening in your data that can't be explained by the variables you've collected. Okay, so there's a latent variable. There's something else in the system which is driving, sort of like if you have two categories of behavior, A and B, and if you look at all the attributes in the database of an object A and an object B, you don't see any distinction. And we were facing this problem with our astronomy data. So my student basically, not that you discover a hidden variable, because by definition it's hidden, but you can just sort of discover the consequences of there being a hidden variable in your data. And so we were doing this work, and we made our interim reports to this company, and all of a sudden the conversation changed from an astronomical application to one of their client applications, and which is they were working with the Veterans Administration to identify veterans returning from deployment who are suicidal. And the problem was that there were all these different kinds of reports that the medical folks at the veterans hospitals had. They had the clinical reports, they had the counselors' reports, they had the debrief from the commanding officers, they had family concerns, there were sort of social worker reports. There was all these different things they've collected, and what they were trying to identify was what's the signal, what's the symptom or the signal that a person gives off who is actually suicidal. And this is a really serious problem for returning veterans. I'm sure you probably have heard the stories in the news. And so at the end of the day, by the time we finished this report and made our final presentation to this company on this project, the whole conversation revolved about the signal detection for suicide patients in the veteran hospitals and how they're going to use the work that we did to aid in that particular study that they're doing for the Veterans Administration. So it's just like we went from studying hidden variables in blue and red galaxies to actually solving a serious societal problem. And that, to me, that sort of spontaneous discovery of the transference of one domain solution to another domain is what I find most exciting about this field.
Just one follow-up on that. I think that is key, right? Because again, as we're talking about big data, I think it's all about linking data. So if you're searching, it's just not about market data, as I said earlier, or it's just not about one thing, it's how you actually bring in everything. So another thing that is very interesting is the search capability within this different sets. We have verticals of financial and services, we have vertical of IP and science. So if you're searching again, IBM or anything for that matter, how can you actually go and search each and everything, and how can you link those data? I think that is the next gen big data. That's what people are looking for, that if you just search one little thing, how can you get everything from that?
We could go on and on for hours probably, but we're gonna have to cut it short here. But we do have time for a few questions, right, Bill?
Yeah. Two questions, please. Yes.
So, am I on?
Yes.
With reference to the relationship between information on a particular individual, for example, Dun & Bradstreet in 2005 launched a product called Customer Defection Alert. So it uses a variety of variables to determine where your business is, who's buying what. For example, if you have a banking customer and your bank customer is all of a sudden looking for loans to develop with another banking institution, chances are they're going to leave you, maybe because you're not providing the kind of service that they're looking for. So Customer Defection Alert gives you the variables that you need to make a decision. As you know, DMB advertisers decide with confidence. You have the information that you need, you now have the confidence to make the kinds of decisions and take the kinds of action that could potentially avert that particular customer from leaving you. So this is something that's been around since 2005. So 10 years later, we're still trying to develop on these same kinds of initiatives. Do you guys have any experience in other financial institutions where this sort of work is going on?
I'll take that. I think it's evolution, right? So what you're talking about 10 years ago, how you actually provided that information. Now I think that information can be provided on demand. And it's just not that information you get. It's so much more that you get with it. It's just not one database that you're getting the information from. You're getting it from 100 different databases. And I think that is the evolution, that is the big data play that has happened over 10 years. Absolutely, I mean, what you're talking about 10 years ago, there will be a lot of innovations that took place, right? But it's the evolution that big data has taken, a lot of things. I mean, take one search, for example, right? Search is just like that. When Yahoo came out, when all these guys came out with search, nobody thought Google would come out and take over. But they added this one very little thing, evolution, I call it, not innovation, which is making it smarter, making algo that if they're searching for Asif Alam, they know exactly what other people have searched and they can get that information. That to me is evolution, and what you're talking about, absolutely, there's a lot of evolution that has taken place in that data set.
So just another comment on that same question. I know another company that I've consulted with that I can't name that's rediscovered what you knew 10 years ago, and this sort of the signal of customer churn. Specifically, in this case, it was a financial client I was consulting with, and one of the things I frequently say when I first walk in the door when I'm asked to help a company is let's look for the low-hanging fruit first. All right. And one of the reasons I say that is you may be familiar with the Netflix prize. So Netflix offered a $1 million prize to improve the recommender engine by 10%, right? So some team won this award. They got the best algorithm, and their algorithm was 45 pages long, and Netflix never implemented it because it was too big and too fragile, okay? So the complex solution, sometimes it isn't a good business solution. And so this company I was working with, they actually, not on my advice, but they did on their own, which sort of confirmed what I believe, and that is they invested a small amount, so it became a cost center. They invested a small amount on a data science team to investigate how to prevent customer churn. And so they basically created something of the type that you described, where it's an early warning system for customer defection, which basically they saw sort of an uptick in the number of clicks. That is, the person was coming to their account more frequently. They were looking at rates, and they were looking at performance. They're looking at all this stuff, whereas in the past, they had very low-level interaction with the online accounting system. Now they're there a lot, and then those customers go away. Well, okay, so what they're doing is they're shopping around and then they leave. And so this company invested like $10 million in a data science analytics team to implement an early warning system based upon all kinds of data, as you said, many different views of the data from many database, of the customer from many different databases. And then after the first business quarter where they implemented this early warning system, the company estimated that they had reduced defections, customer churn, and had saved the business $2 billion in that quarter from a $10 million investment. And so that's the kind of thing that talk about digital transformation. After that, the CEO and board of directors of this company is now going full speed into analytics. The reason I know this is because they're trying to hire like 500 data scientists, so they're constantly calling me. Okay, so they saw what kind of ROI they're getting off of this, and so now they're going full speed into this, and that's where it's transforming from this cost center idea to profit center idea.
And it's the same in enterprises, that picking the low-hanging fruit, identifying an opportunity with real value, real payback, that's the biggest commercial for all those kinds of stuff.
Mm-hmm. Start small, start easy, move from there.
I've got an interesting follow-up to that as well. You could think of the problem, well, not a problem. You solved that problem in 2005 for BND, but no one else knew, right? Because it was proprietary to the organization where you were. So another company thinking about the same thing may or may not have solved that. What this brings to mind is someone asked me earlier today, why do the retailers give us the data that they give us and for us to put it out there? Well, besides the fact that it allows the manufacturers, who are their primary supply, well, their suppliers, to get insights. One of the things, a couple of things it does for them as well is help to solve that problem. So there are tens, 20, say hundreds of retailers throughout the US, and think of all of them trying to solve this. Whereas, because we're getting the data from all of them, we are solving problems like this, and they could then not have to, each one of them, solve the same problems again and again, or even think of the same problems again and again. So that actually is an advantage that they obtain by providing us with data, which they also allow us to share with others. For a while, our biggest retailer, Walmart, in the early 2000s, pulled away from giving the data to us and AC Nielsen, who were the two big players in this field, because they felt they were so big, they were at a loss as against an advantage in providing their data and insights. They recently, about 3 years ago, reversed that because they realized as big as they were, they could actually gain more by sharing their data with us and be able to see what others are doing than if they kept it by themselves. So this shared, that's a use of big data right there. Just by pooling the data so that in a central location, several problems could be solved and everyone could know about it, has turned out to be an advantage to all these retailers throughout the US.
Right, then you can get that network effect as the big data successes keep piling up, right?
Ladies and gentlemen, please help us thank the panelists and Alex.